Welcome to Rges Algebra 2, Lesson 14A. This is covering lessons 311 and 312. We are discussing literal equations and how to work with formulas. Now recall, literal equations means that there's a lot of different variables in the equation, not just the one x, for instance, that you're used to. And when we are solving literal equations, we always need to know which letter or which variable we are solving for. Now, your goal will then be to move everything else, all the other variables as well as constants, to the right side of the equation, leaving only the variable you are solving for on the left. Okay. The technique that you learned in the last section on eliminating fractions can also be used here. And you will probably want to on many occasions, if not all. Now recall that to eliminate a fraction when you're solving an equation, all you have to do is multiply both sides of the equation by the least common denominator. And if you do that correctly, all your denominators will cancel out, and you'll only be left with things in the numerator. So now we're going to go ahead and check and show you how to solve a literal equation, and my biggest suggestion would be to be patient with it. All the techniques for solving these literal equations you already know, but you must think in terms of your rules. Okay, so I'll try to go through this really slowly and deliberately for several examples. So my first example is what I've written down here, and notice I have an x variable, an m variable, and an n variable, three different variables. So this is a literal equation. I need to know which one they want me to solve for, and so they'll always tell you, and in this particular case, you're to solve for x. Now the first thing I'd like to do is eliminate my denominators, eliminate my fractions by multiplying by the least common denominator. And so you can figure out what that is. My two denominators are going to be n and m, and so my least common denominator will be either mn or nm, whichever. I'll write it in alphabetical order. So how do I do that then? I would multiply the left side of the equation by the least common denominator, and I would multiply the right side of the equation by the least common denominator. Notice in the left side, the n's will cancel out, and I'll get m times x plus m squared. You should feel on fairly familiar territory. This should look a lot like our complex fractions at the beginning. My right side, the m will cancel out, and I'll be left with n times, x plus n squared. I will distribute both sides of the equation. And now what am I solving for? I'm solving for x. That means anything that has an x in it. This term and this term belong on the left side of the equation. So I would subtract nx, because right now I'm adding it. So this becomes mx minus nx, and anything that does not have an x in it will go to the right side of the equation. So this will become n cubed minus m cubed. Now I'll go ahead and do some simplifying, but the first step of simplification you need to understand, if I'm solving for x, I'm going to want, that's not the x, I'm going to want to factor out that x, because I want to get it as alone as possible. Now let's do some simplification. You go ahead and you could either watch me, or you could go ahead and give this a try, putting it on pause and coming up for air and checking when you think you've finished. But let me go ahead and put it on pause for a minute. Okay, and here I've solved it on the right side here. What we've done down on the bottom here is we've gone ahead and divided by the factor that's being multiplied by your x, and notice at this stage, right here, I have x isolated on the left-hand side and everything else is on the right-hand side. So now all I have to do is do some simplification. I've gone ahead and factored out a negative sign so that the m minus n would be in the same order, the m's and the n's in the same order in both the numerator and the denominator. So that's what's going on in that next step. And then what I've done is recognize that my numerator is the cube. So I need to remember my factoring of a cube, and that's what I've done here. So go back and look up that formula and maybe make a flashcard if you're not recalling that, because you will still need it. And then we'll factor out our m minus n out of the numerator and the denominator. And it's fine as far as I'm concerned that you would leave that negative sign out front either way. Now I'm going to show you on the next page, however, how we would check that, because we haven't put a lot of emphasis on checking things recently. So let me go ahead and show you my answer, show you the problem, show you the answer, and show you how I would check it. Okay, so in my top line, I have my original question or my original equation. In the bottom line, I have my solution, x equals something. Now choose random values for your m and your n. I would not recommend zeros, okay? But simple numbers. I'm going to choose a 2 and a 1. I'm going to plug those in here to get an actual value for my x. So x equals negative, m squared would be 4, m times n would be 2 times 1 or 2, n squared would be 1, and so my x value is negative 7. So I've substituted any values I choose, avoiding 0, in my m and my n, and I've substituted to get a value for x. Now in my original equation, I have 3 variables, x, m, and n. So if I plug in all 3 on the left-hand side, and I plug in all 3 on the right-hand side, and I simplify them, the left side should equal the right side. So let's check that. And that's what the checking would look like. I've plugged in values for x, m, and n. I've simplified, and I get the left side, negative 3, equals negative 3. That's a true statement, and so I did my problem correctly. Let me walk through a couple more with you. Here's another sample problem. I've noticed my variables are a, x, and c, and I'm going to solve for x. Okay. First thing I will do would be to identify my least common denominator, because I prefer not to work with fractions. So my common denominator, or my denominator here is that, and here is that. Notice I have no c in the left-hand denominator, so there's no sense in pulling out an a, even though I could. My common denominator would be identified as c times ax minus 4a squared. Multiplying the left and the right side by my common denominator, in the left side, that the large term would cancel out, and I'll be left with c as my multiplier times the original numerator. On my right side, the c will cancel out, and I'll be left with my original numerator times the ax minus 4a squared. Now, of course, I'm going to distribute on both sides. I should get cx minus 2c squared equals 2ax minus 8a squared. And now at this point, I need to remember what I'm solving for. I'm solving for the x's. So there's my x term, and there's my x term. Take those to the left side. You get cx minus 2ax take everything else to the right side, and I'll get 2c squared minus 8a squared. Now let's go ahead and factor out my x, and I'll get c minus 2a. You'll always want to factor that out because your goal is to isolate it. So I would just focus on isolating it right now, and I'll do that by now dividing. Oops. C squared minus 8a squared all over c minus 2a. Now, at this point, all I need to do is simplify the right side of the equation. Now, once you've isolated the x on the left side, then it just becomes a question of simplifying. First, notice that I have not forgotten to take out my common factor, and then I recognize what's left as a difference of squares, so I factor that and cancel. Okay, now I've got a solution. Now, at this point, I'm happy with it. They've written the solution by expanding it out. It doesn't matter really. Okay, but let's go ahead and check it. I need a value for A and a value for C. I'll go ahead and plug in. Let's say I'll say the same thing kind of. Choosing very simple values, plugging in for x to get a value for x, I'm going to have c is 2 plus 2 times 1 is 2. So I'll have 4 and inside the parentheses, and 2 times 4 is 8. And so there's my value for the x. And I've already got a value, arbitrary value that I chose for the A and the C. Go ahead and plug all those three in to the original equation, which was way back here. Plug those in and prove to you that they indeed check out. Now I think we'll leave you to struggle with the rest of those and see how you do, and we'll check the answers together, but let's go ahead and look at the word problems 22 through 25. What I would like to do is go ahead and just explain the equation. It says the numerator of a fraction is 8 less than the denominator. So I'm talking about a numerator and a denominator. If I allow my denominator to be x, then my numerator would be 8 less. If each term of the fraction is decreased by 5, so now I'll take that 5 less than that, so x minus 8 minus 5 is x minus 13, and 5 less than that is x minus 5. So now, when I read my equation, so this is the changed equation, right, to this second column here. So now it says if each term of the fraction is decreased by 5, which I've done that, I've shown those here. The resulting fraction, so a numerator over a denominator, this would be the resulting fraction, equals 1/3. And that's my equation. And then go ahead and solve it. Let's look at the next one. It says the sum of the digits of a 2-digit number. So we could talk about the tens place and the units place in a 2-digit number. Okay. The sum of the digits of a 2-digit number is 9. So we would say t plus units, summing the digits, is 9, and their difference is 3. So my second equation would be t minus the units equals 3. Now I can solve that two ways. I could solve it by substitution. I would say t equals 3 plus u and substitute that into the first equation, like that, solving for u first and then for t, or, so that's one way I can solve this, and the other way I could solve is what I call by elimination. Recall this from your Algebra 1, where you're adding the equations. Getting 2t, the u's drop out, equals 9 plus 3 is 12, solving for t, and then going back and solving for u. So both those work here. But my two equations then, in this case I have two equations to solve. Now on 24, we're comparing the ages of Ty and Michael. It says Michael is 15 years older than Ty, so if Michael's x, then Ty would be x plus 15 in 5 more years. So now we have a column for them today, and then a column in 5 years. How old would each be? Each would be 5 years older. So now we have x plus 20 and x plus 5. Taking this one, adding 5 to it, taking this one, and adding 5 to it. Now, it says in 5 years, so we're really interested now in this column, working with this and this. In 5 years, Michael's age, which one represents Michael's age, the x plus 5, would be 1/2 Ty's age, which expression represents Ty's age, the x plus 20. And therefore you can solve then for Michael and Ty's age. So that would be your equation. And number 25, finally, again, I'm looking mostly at helping you with the equations. Chris is 1/2 as old as his father. So we have Chris and his father. Now, to be honest, if Chris is 1/2 as old as his dad, then we know that dad is twice as old as the son. So I'm just going to convert it this way right from the beginning. You don't have to. You could say father is x and Chris is 1/2 x. Either way. Now we're going to talk about a years ago. Not this time a number like 7 years ago, but a variable, a years ago. So this would become a variable or an expression with two different variables in it. A years ago, Chris would have been x minus a, and father would have been 2x minus a. Now we need an equation, so we have two sets of expressions for now and for a years ago. We need an equation based upon, let's see, a years ago he was. So we're going to worry right now about picking up these expressions. So let's read it again. A years ago he was 1/3. So what's the expression for Chris? X minus a. He was 1/3 as old as his father. What's the expression for father? 2x minus a. And then you would solve that. Now in 3.12, what we have are formulas, and I thought that would be easier because I didn't realize they were also having you solve the literal equations before you could go on with them. So got a little more complicated, but let's go ahead and give you, I'll work through the first 3 with you. First, I need to solve for L, and then solve for B, and then solve for H. So if I go ahead and distribute this will probably be the most efficient way to do it. There are always some choices for us, but we'll do 2LB plus 2LH plus 2BH. Now, if I'm solving for L, everything with the L would go on the left side of the equation. So this becomes a negative 2LB minus 2LH, and everything else goes to the right side of the equation, and I'll get I'll get negative S, I could write it the other way, but plus 2BH. Now, I'm solving for L, so I want to factor out the L. I'm going to go ahead and divide, this is an S, so that I isolate the L on the left side. And I'm going to clean up the signs. By that I mean that I've got this here with two negatives, so I'm going to pull the negative out front, changing this to 2b plus 2h. Now I could also clean up this, combine these two signs if I want, by changing this to s minus 2bh. So there's several varieties that you can do this, but I like that one. So now I'll get s plus 2bh all over 2b plus 2h. Do not be tempted to cancel anything because, of course, you have to have factors, and this s does not factor in to the rest. So that would be the equation. Oops, I think I did that wrong. Yeah, I needed this negative here. Sorry. I think I said it, but I didn't write it. Okay, so factoring out this negative over here, I'm reversing the signs, and I'm going to get s minus 2bh. And that's the equation for what L equals. So you'll do a very similar process to solve for b and to solve for h. And then finally, they'll ask you to use that formula. You'll have to decide which formula. It says find the height, so I want the h formula. Find the height. So start with the formula that begins with h that you solved above, and then you'll plug in values for the length. The length is 6 feet, and the wide, 4 feet wide. I don't have a W for wide, so that would be the same as breadth. And then they'll give me the surface value, which is 108 square feet. And so you'll pick up your formula from above that has h equals. You'll plug in the length, the breadth, and the surface area, and you will solve for h. That's essentially what you're doing with all of these. So actually, I'm not sure that I need to show you another except for the second one. I thought the second one was very obscure in the way that they talked about it. I really had a hard time with the idea of percentage and rate and identifying those in the problems. So I wanted instead to just, now you can solve for B and for R just as you did with literal equations, but when it came to B, C, and D, I want to just talk those through with you, ignoring really their formula, which I think is, the terms are very confusing. But if it says, if nickel steel is 2.85% nickel, how many pounds of nickel, so I'm looking for the pounds, are there in 2 tons of nickel steel? Okay, so we have 2 tons, so I write down the information I have. 2 tons of the alloy, the nickel steel alloy, and I have, of that, 2.85% is nickel. Now let's just take it back to something I would ask for. I'm saying, what if I said, if I have 10% of a value, okay, let's say 50, how much would I have? Well, notice that's a multiply, right? I would simply multiply, if I had a problem simple like this, I would multiply 10% or change it to a decimal, 0.01 times 50, and I would get my answer. Okay. So up here, all I would want to do is change my percent to a decimal. And here I would multiply 0.0285 times 2 tons, but I want my answer in pounds. So 2 tons is how many pounds? Be 2,000 pounds. So make sure you do that conversion, and when you do that, you get your answer. So for C, it says, out of a lot of 360 brass castings, so I have 360 brass castings, 24 are spoiled. I write down my information, what percent, and I write down what I'm asking. Okay. Well, again, think of something very simple, let's say, so if I'm thinking of what percent, if I have 4 questions out of 20 questions, I like to go back to things I understand. Then what's the percent? And you know how to do that. I think you would just take it, make that a fraction, and convert it to a decimal. That would be 1/5 or 20%. Okay, so here what would I do? I would take 24 over 360, convert it. I could either simplify it first or convert it to a decimal, whatever I want to do, okay? And then convert it to a percent. In other words, this is, let me go back to this one. So you convert it to a decimal and to a percent. Okay, I did that maybe fast here. I would have converted this to, which is 0.2. There's my decimal. And then taking it over 2 places would be percent. And then finally, let's look at one more here. D. Again, for this one, I'm just more looking at this logically. It says the mower deck of a diesel golf course mower requires 16 horsepower to run. If 20% of the power of the engine is lost through friction, then how much am I going to actually use of the original amount I composed? Of the original amount, I'm using 80%. So I want 80%, right, of the original amount of power. And that's it. So the question is, what is the minimum horsepower that the engine must produce to run? So that's the original amount. That's what my question is. And 80% of it is the 16. Okay. So how would I do that? What I'm saying is 80% of what is 16. And if you recall anything about relating to percentage problems, you would just say 80% of x, so I would convert that to a decimal, 0.80 of x is 16, and dividing x equals 16 divided by 0.80. Recalling some of your arithmetic here, this would be 16 divided by 0.80. I'd pull that, just pull it over one place. Don't be ridiculous here. Pull it over one place, pull that over one place. 8 goes into 16 too, and have that 0. So the answer is, originally I would need to produce 20 horsepower so that when I've lost 20% of it, it will be 16, which is what I need.